Okay, excellent. So, good morning, everyone. Thank you, Chairman, for allowing me for the presentation. So, I'll be speaking on the comparative analysis of solanine content in the wild, hydroponically grown and homegrown varieties of the nightshade. Now, before I move to the presentation, I would like to highlight the importance of the hydroponic system. As one of the speaker previously discussed about the COVID-19, so during COVID-19, I think the most of the people were growing the food at home, and hydroponic become very popular. And hydroponic is a system wherein you can grow the plants in water using the nutrients. And on the another end, the population is growing and land is limited. And there is a concept of now terrace farming and the narrative of the grow your own food, and due to the safety concern of the foods and I mean especially fruits and vegetables contaminated with the insecticides and all. So now the trend is going for the hydroponic farming. Now so far there is very less research or studies done on the plants which can be grown by the hydroponic, especially for the medicine purpose, especially for the herbal medicine. So our research group had actually started doing some research, and we have published previously also on some of the other plants. So today's discussion is on the Solanum nigrum, which is from the which is also known as the black nightshade. It is from the family of the Solanaceae, this plant, and this plant has got a traditional use. It was used earlier in the traditional medicine, and this contains some of the secondary I mean the metabolites like alkaloids, flavonoids, and glycosides, which are being used earlier as in traditional medicine, and it has got the marker compound, which is the solanine. Now, some of the work which has previously been done on the hydroponic versus the plant which was grown in the wild and also in the cultivated setting. So, what was the purpose of the study? The study was done because of certain reasons. The first reason is the problem with the standardization in the herbal medicine. So, whenever there is any herbal medicine or raw material for the herbal medicine, there is always issue with the biochemical variations. So, if the plant is grown in a different setting in different part of the world, it will have a different phytochemicals, especially the content, or maybe the marker compound may remain the same, but the variations can be there in the phytochemical profile. So, if we can grow these plants into the controlled environment with the nutrition, with the you can say a proper nutrition and controlled environment, we can even reduce those variations. So, another issue is, as I mentioned, that uh, there's a external factors and there are some internal factors which can do the variations in the chemicals, and we can control those variations by giving the optimized nutritions, and which will enhance the, of course, the marker compounds. And there are some toxicity concerns also. Let's say in the Solanaceae family, as we know, there are many plants from this family, like the Tura is there, and there many are other plants which has been used in the medicine. There are some toxicity concern, and we can even reduce the production of these toxic compounds when we can control the environment and the nutrition. So that can be done. So objective of the study was to compare the pharmacognostic profile and phytochemical profile of the differently grown Solanum nigrum. So what we did, we grown this plant in the three different conditions. We grow the plant at home in the soil, and then we grow the plant in the hydroponic in water, and also we collected the plant from the wild sources. Now we did the comparative study to check whether these plants have some kind of variations in the phytochemicals, morphology, or their phytochemistry, or it's the same. So these are the pictures of the plants which were grown. Now, in the research methodology, we collected some plant samples from the wild sources grown hydroponically, and then did the extraction and used HPLC method for quantitative analysis. We did the phytochemical screening for the qualitative analysis. And this is the graphical representation of the work. And this is how the extraction was done. And now coming to the results and discussion. So we found that in the morphological evaluation that there was no much difference in terms of the the chlorophyll content. Of course, in the wild there was more of chlorophyll content, and the leaf size was, of course, very small in the hydroponic and medium in the homegrown, but larger in the wild grown, you can say, plant in the setting. And the stem also was thin in the hydroponic, medium at the homegrown, and very thick into the wild variety of the plant. Now, coming to the microscopy, what we did, we used the Dagendorf reagent, which is used to identify the alkaloids. So, since our focus was on the alkaloids, so we used the Dagendorf reagent and did this study. So, we found that the content of the concentration of the alkaloid was high into the hydroponic, and which was followed by the homegrown and very less into the wild grown variety. So these were some of the phytochemicals which were identified by using the different chemical tests. And we found the presence of the alkaloids, flavonoids, tannins, saponins, and these were the tests used for identification of these phytochemicals. And these are the results. And then we did the HPLC analysis to identify the difference between the phytochemicals. And as expected, we found the highest number of the you can say the total area or the total height of the peak and area under curve was more into the hydroponically grown plants. So as you can see here, which is shown in the blue color, this is the hydroponically grown you can say the plant wherein you can see the peak height uh, is more, area under curve is more, and total height of the peak is also more. So that means that the compound which is there into the hydroponically grown plant is higher than the other, you can say the plants which are grown into the homegrown and the wild, you can say the settings. So in fact, we did the literature review and we found that the retention time for the Solanine was around 4 and ours was also like you can see 3.6. But of course, we have to further go with the study to do the HPTLC and LCMS because this is just the preliminary findings of the results. So our work is still in progress and we are going to do the HPTLC and LCMS to check the complete chemoprofiling of the comparative study of these plants. So that's a conclusion that the hydroponically grown Solanum nigrum produce the highest amount of the alkaloids, especially the marker compound, which is the Solanine, which is more likely. And we will have a less, you can say, the variability of the secondary metabolites if they are grown into the hydroponic settings. So this is our future plan for the study. That's all from me. Thank you.
Thank you so much. Thank you for obeying the time limit. Thank you, Dr. Sekawar. Thank you very much, and for your interested topic also about the phytoconstituents profile, especially the